Hi, I am Maniandan, doing ME Structural Engineering Weltech High Tech. This is my final semester project work. Design of innovative cold form steel sheet to slip failure mechanism by pull out method for composite slabs. My internal guide is Mr. R. Raghupati, Assistant Professor in Weltech High Tech Engineering College. Aim. The aim is to understand the steel concrete slip mechanism and its dependence on various embossment shapes in order to improve design for composite slab. The main aim is to find the slip mechanism because most of the structure, as far as composite structure is concerned, the main failure is occur in between the steel concrete junction, that is the slip zone. So that's why I am selected this project. Objective. A new steel sheet design has to be developed and optimized by several pull-out tests for various shapes of embossment for dovetail slips. And FEM model has to be developed to stimulate the longitudinal slip mechanism of composite slab in pull-out test by using Abacus software. This is the two way that I am going to test the specimen. One is by numerical testing, that is by using Abacus, and by experimental method by using pull-out test experimentally. Scope of the project: to create innovative cold form sheet with ultimate slip resistance and to create a pattern right, because in most of the composite structure they used to fail on that particular zone. By changing the embossment shapes and its parameters like slopes, depth, and other type of physical parameters, we can able to achieve a maximum slip resistance that will act as a shear key. So that's why I am selected this particular embossments, that is three embossment that it has been created using a die. In hydraulic pressing machine the embossment was created. Second point is the availability of existing cold form sheet in the market is replaced with a new form of sheet with different shapes of embossment. Already there is some shapes are available in industry. We have selected three different shapes that is not actually available in current market. For that I am going to test the specimen maximum slip resistance and I am going to compare it with the existing sheets. That it will increase the efficiency of the composite structure against slip failure mechanism compared to previous stages of CFC. That is, the already available material that will give minimum slip resistance and compared to that of the shape that it has been selected by me currently. Introduction. The longitudinal slip between the steel sheet profile and the concrete in composite slab is usually an inefficient failure mode, because I already told, usually the composite structure fail in between the steel concrete zone. The slip is associated to longitudinal shear force developed in simple bending. As far as the slab is bent by simple bending, there will be a longitudinal shear force occur in between that portion. In order to improve the longitudinal shear strength, the current profile is replaced with the new shapes of embossment. For that only we have selecting a different embossment that will provide a maximum shear key action with the sharp edges like that. That will provide a maximum slip resistance. Apart from that, by reducing the spacing of the embossment, we can achieve a maximum grip. This is the pull-out test setup. In this, the specimen has to be placed in position and fixed. The specimen is made up of three different forms of embossment and with plain sheet. The test result has to be compared with the embossed sheet and without embossment specimen. Actually, we are using three different shapes of embossment like chevron, tablet, and rectangular shape. Work done in phase 2, that is in this semester. The CF sheets are bent to dovetail shape and embossed for three different shapes of using hydraulic machine pressing in a workshop located near Gindi and received on 8th of February. The size of the specimen is 150 by 350 mm. Following are the shapes of embossment: rectangular 25 by 21 mm, chevron 60 by 30 mm, tablet 25 by 5 mm. Apart from the experimental method, by using numerical method, Various CF sheets are prepared without embossment and with embossment for various shapes like three shapes. This is the abacus model. First of all, we have to create the CF sheet model. After that, it has been incorporated with the concrete. Then it will act like a composite structure, both the steel and concrete in monolithic form. After getting the CF sheets from the hydraulic pressing machine, then the CF sheets are welded with the tuning fork like shape reinforcement. This will act like a top fixing portion that will pull the sheet from the concrete on top side. It has been clear from the previous slide. It will shows only the CF sheet. First of all, we have to model the CF sheet. This slide will shows the composite model. The steel sheet is incorporated with the concrete. This is the actual full specimen. The top portion is pulled up from the tuning fork like shape that it has been welded on the CF sheet top portion. The bottom portion is pulled down by using a tuning fork like shape reinforcement. The reinforcement was inserted by using a lock fixing chemical to create a higher bond strength while pulling out the concrete. It should not break up on that particular position. For that, we selected a particular type of lock fixing chemical, that is Resifix G from the post rock chemical. After drilling a hole on a concrete, the tuning fork like reinforcement was inserted on that, and the lock fixing paste was fixed and packed around that. Actually, the same model has been created by using abacus software. The same parameters, same boundary condition, same loading condition, like that. This is the overall composite specimen by using abacus software. This is the abacus model in the standing position. This is the actual specimen for experimental method. It has been clear from the photo that the steel plate is placed in center of the cylinder. On the bottom portion, the steel rod is packed by using a Resifix G chemical, that is lock fixing chemical. The top and bottom portion was pulled away by using universal testing machine for this testing. These are all the cold form sheet that has been welded after getting it from the hydraulic pressing machine. This is the second part of our this is the second stage of our project. After getting the specimen, the next step is welding it with the tuning fork like reinforcement. Lock fixing chemical was selected for bonding the concrete with steel to create a monolithic nature to pull the concrete on UTM. Resifix G polystyrene resin anchoring grout hardener from Chico Technologies Limited. Material parameters of steel and cement selected for our test are steel, that is 12 mm TMT bar, and cement of PPC 53 grade. Problem definition. The pull-out test. The study aims to understand the steel concrete slip mechanism in experimental study. The specimen is cast by dovetailed CF sheet with one rib form of composite member for without embossment and with three different forms of embossment, which is not available in the market. By using a cylindrical specimen, we are casting this. They are tested for 7, 14 and 28 days of curing. This is the graph for a chevron shape embossment. The maximum slip occurred in 7 days of curing, that is 7 mm. As far as 14 days is concerned, the maximum slip is 5 mm. For 28 days of curing, the slip is more than around 4 mm. The maximum load is 35 kN, that it has been resisted. After that 35 kN, there will be no change in the slip resistance. There is this is the ultimate load with the corresponding slip. This is the experimental result from rectangular shapes of embossment. The maximum slip occurred is around 13 mm for 7 days of curing. As far as 28 days of curing is concerned, the maximum slip was 8 mm, that has been occurred in 35 kN. Maximum the load will resist up to 35 kN. After that, there will be a reduction in load. This graph shows the tablet shape embossment slip resistance. The maximum slip resisted by the tablet shape embossment is 16 mm for 7 days of curing. As far as 28 days of curing is concerned, the value will be around 6 to 7, that is around 7. The maximum load that has been resisted was 34 point something, that is around 35 kN. This graph shows the without embossment sheet slip resistance. The maximum slip that has been resisted by the shear sheet was 23, around 23 mm. As far as 7 days of curing is concerned, as far as 28 days of curing is concerned, maximum slip resisted by the specimen was 14 mm, 13 to 14 mm. The peak load was 35 kN. This is the numerical result for a chevron shape embossment. The maximum slip that has been resisted by the chevron shape embossment is 6 mm. This shape is more resistive when compared to that of two other embossment shapes and without embossment sheets. This result is somewhat more resistive when compared to that of experimental method. So there is a difference in result between the experimental and numerical method is around 20 to 30%. The maximum difference will be around 25%. This graph shows the slip resistant capacity of a rectangular shape embossment. In this, the maximum slip resistance will be around 11 mm. When compared to the top chevron shape embossment, this will be lesser resistive. So it is better to select chevron embossment as far as rectangular shape is concerned, or compared with the chevron shape. Comparatively, chevron is better. Rectangular is somewhat inferior to that of chevron. This graph shows the slip resisting capacity of a tablet shape embossment. In this, the maximum slip resisted by tablet shape embossment is 14 mm. It is comparatively more slip to that of rectangular. So, chevron is better than rectangular. Rectangular is better when compared to the top tablet shape embossment. So it has been clear from the three shapes of embossment, the best one is chevron shape, that will resist the maximum slip. So the graph shows both numerically and experimentally the chevron is best than any other shapes of embossment. This graph shows the slip resisting capacity of without embossment sheet. The graph shows the ultimate slip that has been occurred in this was around 19 mm. This is the ultimate slip when compared to other three embossment sheets. So this will show without embossment sheet will not that much slip resistive when compared to the top embossed sheet. So it is not economical and structurally not suitable for some particular composite structure. Finally, we came to the conclusion part. The following are the points that has been observed and collected from the experimental and numerical studies in the 2 semesters, that is from phase 1 project to phase 2 project till now. The first point is the specimen are cast with shear sheets at the middle of the cylinder, such as with embossment, without embossment for pull-out test, and they are tested for 7, 14 and 20 days curing. Then the cast specimen are tested by pull-out method in UTM, and the results are plotted through a graph for load versus slip failure mechanism of composite structure for various types of shape sheets. From the experimental result, it has been clear that the maximum slip was resisted by the chevron shape embossment because of its maximum shear key action. The maximum slip occurred by experimental method for 7, 14, 28 days of curing for chevron shape embossments are 7, 5, 4 mm respectively, with the failure load of 35 kN. The chevron shape embossment shows this much of slip for the ultimate load of 35 kN. The maximum slip occurred by the experimental method for 7, 14, 28 days of curing for rectangular shape embossment. Already we discussed about the chevron shape embossment. Now this point indicates the rectangular shape embossment, that is 13, 9, 8 mm respectively. After that, the maximum slip occurred by the experimental method for 7, 14 days, 28 days of curing for tablet shape embossment are 16, 13, 7 mm respectively. It has been clear that from the 3 shapes of embossment, the best one is chevron, that will resist the maximum slip. The maximum slip occurred by experimental method for 7, 14, 20 days of curing for without embossment are 22, 17, 14 mm respectively. So without embossment sheet will not that much slip resistive when compared to that of embossed sheet, especially as far as chevron is concerned. Other 2 embossments are inferior. So the result shows that the chevron shape embossment is 62.2% more slip resistant without embossment sheet, and 56.3% more slip resistant than tablet shape embossment, and 46.2% more slip resistant than the rectangular shape embossment. The maximum slip occurred by numerical method for chevron, rectangular, tablet and without embossment are 6, 11, 14, 19 mm respectively. Comparative study of numerical and experimental results were made to select the best type of embossment which resists maximum slip. From the comparative study, the experimental result showed more slip than numerical analysis, and it is under permissible range. Following are the percentage of deviation between the experimental and numerical method. There is a little bit deviation from the experimental method and numerical method. The following are the percentage of deviation, that is 14.28%, 15.4%, 12.5, 13.6 for chevron, rectangular, tablet and without embossment sheet respectively. Reference: I used the reference of some international journals. The following are some of the journals that I used for making my project a grand success. Thank you to everyone for supporting my project. Thank you to one and all everyone.